From a report, Airline Quality Rating 2016, it included the data on on-time arrival percentage and the number of complaints filed for 100,000 passengers for U.S. airlines. Now, the report did not include data on the number of complaints for 2 of the airlines, but there were many other airlines that it did include data for. We could use the given data from the other airlines to fit the least squares regression line and use it to predict the number of complaints per 100,000 for those 2 missing airlines, Spirit and Virgin America. So how do we do this, and how confident are we going to be that our prediction for these unknown values is going to be correct? So in section 4.3, we're going to assess the fit of this line. So once you have the equation of the least squares regression line, probably through software, the next step is for you to look at how effectively the line really summarizes the relationship between x and y. First, is the line even an appropriate way to summarize the relationship? Should you have done something more sophisticated that's beyond the scope of this class? Are there any unusual aspects in the data set that you need to consider before using the least squares regression line to make predictions? Are there some outliers? Are there some sections of the line that are a little iffy and should not be included when calculating this regression line? A third question that you might want to consider is if you decide that it is reasonable to use that least squares regression line as a basis for prediction, how accurate can you expect these predictions to be? So when we talk about this predicted value, we're going to use this equation in order to predict values that we don't necessarily have in our data set. So if you needed to make a predicted value, I want you to consider the first observation in the data set, x1, y1. So that's for our first individual, we have the x and the y values for that. You can substitute x1 into the equation. This equation is not going to give you the exact y, it's going to give you a predicted y based on this regression line. That's why it has the little hat above the y to help you know that we're making a prediction. Now, sometimes the predicted value will be exactly the actual value, but that rarely happens. Usually there's some difference, and we call that difference the residual, where you take the actual value minus the predicted value. Now, often you will not be able to calculate the residuals for some of your unknown values, but you'll always be able to calculate residuals for the values in your data set, because you'll always be able to calculate the difference between what actually happened in the data and what your line predicted would have happened. So take a look at this simple example. The actual value x1, y1 and the actual value x2, y2 are here, not on the line. The predicted value has the same x, but you have a predicted y, and then the same x2 with a predicted y2. You'll notice that y1 is greater than the prediction, and so when you do this residual calculation, you get a positive residual. It is above the line, the observation is. And then when you take the observed value for 2, subtract the predicted value, it's going to be a negative value. And so here your residual is negative. In a good scatter plot, you should have some positive and some negative residuals. So let's take a look at example 4.6. And this is a study where they look to see how far these let's take a look at example 4.6, where we have data that's actually a subset from the entire data set that appeared in this study, small mammal responses to fine woody debris and forest fuel reduction in Southwest Oregon. So what they were interested in is to see how far a deer mouse would travel for food related to the nearest pile of woody debris that they could hide from. You imagine a little mouse in the woods would want to have protection from some of the predators. So they wanted to see how far these mice would be willing to travel. So here is a printout of the subset of data, and I'm actually going to load this into StatCrunch and show you how we can calculate all of the residuals for this data set. I have the data from example 4.6 loaded into StatCrunch. If you want to get the predicted values, usually it will not be provided with your data set. This one just happened to have the predicted values with it. Usually you'll only have the X variable and the Y variable observations. So if we go to Stat, Regression, Simple Linear, and select our X variable and our Y variable like we've been doing, what you need to do is scroll down and save the residuals and the predicted values. If you are using a Windows machine, to select more than one option, you need to hold down the Shift key while you're clicking all of the things that you want. If you're using a Mac, you need to hit the Command key and hold down click everything that you want. If you forget and you hover, it will tell you what to do. And that's all we need to do. Click Compute. And so here you'll notice that I got all my residuals and I got all of the predicted values, which the data set came with, but usually it wouldn't, and it was super easy to obtain.